This module, you will learn about isomerism. Let's take a compound with the molecular formula C4H10 to understand this concept. If we were to draw the structure of C4H10, we could draw it in the two ways shown here. Both the compounds have same number of atoms. That is, 4 carbon atoms and 10 hydrogen atoms. Thus, their molecular formula is the same. The name of the first compound is N-butane and the second compound is isobutane or 2-methylpropane. Both these compounds have different properties. The phenomenon of existence of two or more compounds with the same molecular formula but with different properties is known as isomerism, and the compounds are called isomers. Thus, N-butane and isobutane are isomers. Isomerism can be of two types: structural isomerism and stereoisomerism. The compounds that have the same molecular formula but different structures are known as structural isomers, and the phenomenon is known as structural isomerism. For example, in N-butane and isobutane, the molecular formula is same but their structures are different. Thus, they are structural isomers. Structural isomerism can be of following types: chain isomerism, position isomerism, functional group isomerism, and metamerism. Let's look at chain isomerism. Compounds that have the same molecular formula but different carbon chain, that is, straight or branched chain, are known as chain isomers, and the phenomena is known as chain isomerism. For example, the following 3 chain isomers are possible with molecular formula C5H12. They are N-pentane, isopentane or 2-methylbutane and neopentane or 2,2-dimethylpropane. Here the carbon skeleton is different in each compound, but the molecular formula is the same. Now, let's look at position isomerism. Compounds that have the same molecular formula, same chain, but which differ in the position of the substituent or functional group are known as position isomers, and the phenomenon is known as position isomerism. For example, the molecular formula C3H8O represents 2 position isomers. In case 1, the functional group OH is attached to the first carbon atom. Hence, the name of the compound is propan-1-ol. In case 2, the functional group OH is attached to the second carbon atom. Hence, the name of the compound is propan-2-ol. In both the compounds, the molecular formula is same, but the position of the functional group differs. Next, let's look at functional group isomerism. Compounds that have same molecular formula but different functional groups are known as functional isomers, and the phenomena is known as functional isomerism. Propanone and propanal represent 2 functional isomers having the same molecular formula, C3H6O. Here the functional group differs. That is, in case 1, ketone is the functional group, and in case 2, Aldehyde is the functional group. Some examples of functional isomers are alcohols and ethers, cyanides and isocyanides. Finally, let's look at metamerism. Compounds that have the same molecular formula but different alkyl groups attached to the same functional group are called as metamers, and the phenomena is known as metamerism. This type of isomerism occurs due to the difference in the nature of alkyl group attached to the functional group. Metamers always belong to the same homologous series. Let's consider the molecular formula C4H10O. The following isomers can be drawn, that is, methoxypropane and ethoxyethane. Here the alkyl group attached on either side of the functional group is different. In case 1, methyl and propyl are attached to either side of the functional group, and in case 2, ethyl groups are attached to either side of the functional group. Metamers may also be regarded as positional isomers. Some metamers are ethyl aminoethane and methyl aminopropane, 2-pentanone and 3-pentanone. Now let's look at stereoisomerism. In Greek, stereo means space and meros means paths. The isomers which possess the same structural formula but differ in three-dimensional arrangement of atoms or groups in space within the molecule are known as stereoisomerism, and the phenomenon is called stereoisomerism. Stereoisomerism can be of two types: geometrical isomerism and optical isomerism. You'll learn about these stereoisomer types in higher classes. You have now reached the end of this module. In this module, you have learned that the existence of two or more compounds with the same molecular formula but different properties is known as isomerism. The compounds themselves are called as isomers. A compound having same molecular formula but different structures, that is, the way by which the atoms are linked, is called as structural isomers, and the phenomena is known as structural isomerism. Compounds that have the same molecular formula but different carbon chain, that is, straight or branched chain, are known as chain isomers, and the phenomena is known as chain isomerism. Compounds that have the same molecular formula, same chain, but which differ in the position of the substituent or functional group are known as position isomers, and the phenomenon is known as position isomerism. The compounds having same molecular formula but different functional group are called as functional isomers, and the phenomenon is known as functional isomerism. The compounds having same molecular formula but different alkyl group attached to the same functional group are called as metamers, and the phenomenon is known as metamerism. The isomers which possess the same structural formula but differ in three-dimensional arrangement of atoms or groups in space within the molecule are known as stereoisomerism.